So first of all, I'm going to start with the geometry, right? And I'm going to create a part one, which I'm going to name it as a cube, or let's say a concrete cube, 3D deformable solid extrusion. So the approximate size here, I'm going to put 150. Then I can go on. So now I can draw my sketch. Let's take the rectangle. Let's start in the origin. Let's go like that. So now I'm taking the dimension. Dimension here is going to be 100 millimeter. I'm taking this, not this one, but I should take the height here. The height here, let me click again. Let's take the height, it's gonna be 100 millimeter as well. So now I just draw a square. I'm gonna click here, and then done. Now I'm gonna put 100 millimeter as depth. So then I'm gonna have a box. So this is my cube. So I already finished my geometry, right? So what I can do right now is to set up the partition of the cube into layers. So what I'm going to do is to go on here on tools. So I click tools, then I'm going to datum, and then I'm going to click on here. Sometimes it will start on point, you will click on plane. So you will have offset from principal plane. So if you click offset from principal plane, you can see that the vertical one, this face, we have it on X, Y or YX. So I'm going to choose this one, right? So I click this one. So now I know that my rectangle or my cube, when I was sketching it, I started on the origin. So that's why if I put 10 millimeter, it's going to start from the origin to 10 millimeter. I click OK. You will see on here. If I rotate here, let me just zoom it. If I rotate, you can see, the origin to here is 10 millimeter. So now I'm going to create another one. So let's deselect on here. So I'm clicking it as well, and I'm going to give 20. So I have another one. I click as well. I'm going to have 30 because I'm creating these principal planes so I can create a partition. But first, I'm going to do this step. So 40 and now 50. I'm going to go to 90, right? So 60, 70. I'm going to go 80. And then the last one, 90. Okay, so now I have all of this. So now that I already created the the datum planes, I'm going to use tools, then partition cells. I'm gonna click on use datum plane because I already created them, and these are the datum plane. I click the first one, create partition. So I have the first one. So the second, I'm going to click all of it first, then I'll click on done, and then I'm going to click the second one, then create partition. So I click all of it, done, and the third one. So this is the way you create partition, done, and then the other one, the fourth one, and so on. Okay, all of it, done, this, create, the rest. So you do all of this till you finish all those planes. So this is the way you do it. Done. Then you click on here. Now the last one will remain. This is the last one. So now we are clear. We can rotate it. Now we have all of our partition created. So now we're fine. The partition are created. So now we can move to properties. So I'm going to properties here, property. Yeah. So I'm going to use only one, material one. So it's going to be a steel, isotropic one. You can choose to create a composite material. Especially when you have partition like this, but that's not what I'm going to do. But if you guys really interested in it, you can just tell me and I'm going to go with it or just explain you how to do it on the comments. Yeah. So density 7,900. Let me just consider that. So now mechanical elastic, I can give the Young modulus 210,000. That's the megapascal. Now the Pressure ratio 0.3 is okay. So you can also go on the plasticity if you want to model a failure. If you want to model a failure, or you want to capture how to say, you want to capture plastic, you can go on it, but that's not the objective of this tutorial again. So I'm just remain on the elastic model, right? So now, okay, I already created my material. What I'm going to do right now is to go on assembly. I'm going to create an instance. This is a mandatory step to do on Abaqus. I already created it. Now I will go to step. So on step, this is very important because we already have an initial step. So if I go on manager here, I can see an initial step. So this initial step is correct to have it when you only create the interaction. So you can use this initial step. But if you want to apply boundary conditions, you need to create a step to tell your boundary condition, whether it's a load, whether it's a boundary condition, I don't know, but you need to create a step so you can assign it to your boundary condition so the software will understand how the boundary condition is going to apply. Let's, for example, create a step. This step, I'm going to name it as loading step. So this step, I'm going to assign it with the load. So the load is going to use this step. Okay, so this step but before I choose here, I have general, I have linear perturbation. I'm going to remain with general, but have many types here. I'm going to click on static general because this is a linear static analysis. So continue. So now the incrementation, I can choose 0.001 as initial. This, I keep it as it is. And here I can put 0.1 for the maximum. So now, okay, my step is okay, but I can go on edit. I'm going to show you guys something. So here we can see the NL geometry. So this is the non-linear geometry. If you want to capture more plastic and stuff, you can go on, but here we will not have large deformation, so we just keep it as off. So now let's go on interaction. Interaction. Here on interaction is the most important step. So what I'm going to do, first of all, before I create the interaction, I need to create surface. So why I need to create surface? I need to create surface. But before I do it, I need to go back on property. There is a step that I forgot. Here on property, I will create the section and then assign to my model. So here I need to create a section here. Section 1 is okay, solid, homogeneous, continue, and then it's a steel. That's what we had. We only have one material. So, okay, and now we will assign that section that we created into our part. So I click on here, I will select everything, and then done. Section 1 as I created, okay. Now we see the change in color. That means that it's okay. So now we already did. So I already created the assembly part, the instance. I already created the step. Now interaction. So let's start. But before I create interaction, I need to create surface. So to do that, I need to go on tools. I need to go on surface, and then manager or create. Let's go on create directly. So this is surface 1. So let's go surface 1 top. This is going to represent the first layer. So let's go on, let me turn it like that. Yeah, so this is going to represent the layer 1, the top layer 1. So done. And I'm going to create another one, but let's go on the manager like that. So it's going to be easy. So create surface 2 top. not top, and then continue. I'm gonna click on here and then done. So I'm gonna create another one. So I will do this. I will create another one assigned to here, here till finish, and I will create some other ones in order to how to say, in order to assign for the ones that are on the bottom in here, because I'm gonna need them on the interaction. So I'm going to cut this on the edit, but you will see so many here because I will just create for all of them, but it will take more time. So I'm going to cut it, but you just saw how to create them because I already created for the two ones. So now you can see that I already created all of it. These are for all of these on the top. Now I'm going to create some other ones that I'm going to assign for the ones that are on the bottom. So the first one is going to be this. So the surface one bottom is going to be this one. It's going to be this one. Then done. And also until finish all of them faces. So now, as you can see, I already created for all of them. So now I have all the surface created. Now I can go on creating the interaction, right? So create interaction one. So it's gonna be 1, 1. That means the one in the top and the one in the bottom. So I'm gonna click on surface to surface contacts. This is the one I'm gonna use. Then continue. So now I need to create the two surfaces because I need to have interaction between the top and the bottom surfaces or faces. So now I'm going to click on this one here in the bottom and then done. And I'm going to click on surface. So if for now, let's just do it. If you guys really want to know more precision or more explanation on this, you can ask me. Maybe I'm going to do a video into dedicating to explaining all of this because it's very advanced. This is not for beginners. This is very advanced. So I need to have more time into doing it so I can you guys show you the way. Why we are doing it like that. So I create the surface in the top and the bottom. So now I'm going to assign the contact interaction property. So I will create them here, and then I have contact. So this is interaction property one. I'm gonna only create one because we can create many for all of them interaction, but I'm gonna create one for all the interactions. So I have contact, continue. So now if I click on mechanical, you can see all the types of interlayer bonding you can choose. You have tangential behavior, you have normal behavior, have damping, damage, fracture criterion, and cohesive behavior. So I'm going to tell you what the three, tangential, normal, and cohesive, because these are the most common one that we use. So the tangent behavior is the one that permit a little bit of sliding. You can define that they are sliding a little bit, and you put a coefficient in order to define how much sliding we have, or how much of just sliding. It's a tangential behavior. Yeah. So it's more like if, for example, now we have the normal one, the normal behavior. This is normal one. You can go on hard contact and stuff. You can already contact them already hard, or just define them as bonded, right? And the cohesive behavior is the most realistic one because it allows some partial bonding, but sliding again, and even failure, delamination. So the three types are covered on there. So this is the more realistic way, but but it requires more elements and it's a bit difficult to mesh. So for me right now, as it's for beginner, I will choose the tangential behavior. So here I can set it as frictionless, and I can also go on penalty and assign some coefficient of friction. friction coefficient is going to be 0.001. I think this is okay. Now, okay, I already have it. So it came on here. If I had created many, I would have them here, but I only created one, so I only have it here. So, okay, this is the first interaction. You can see all of it. So now, guys, I will create the second one. I'll click on here, interaction 2, means the two top and the layer 2 on the bottom, surface contact, to surface contact continue. I'm gonna click on the one here in the bottom. Let's click here, done, then surface, and then as I say, if you want more details about why I'm doing this way, you can ask me. But for now, this is the way you create interaction in this scenario. So now I'm gonna edit because I'm gonna do for all of them, and it's gonna take more time. So I'm gonna cut it, but I already saw how to do it. So now you can see that I already created all of the interactions in here, from top to bottom in each layer here. So I create interaction and I click at the first time the one in the bottom and the second the one in the top. So this is the way you do it. If you want explanation, as I said, you can comment and I will tell you why. So now you can go on the manager and check all of them. You can see that I created all of them, but the problem I created, it's not really a problem. I created all of them in the loading step, in the step that I created. And it's very, it's, how to say, it's very well advised that it's good or even better to create the interaction from the initial step. Only the loading that you will start at the step that you created in this. But now I can just move left here. Okay, this is interaction. It's okay, or it's better to do this way. So move left. The from the time you were creating the step, the interaction, you could have start directly in the initial step, but I didn't pay attention to it. So if you guys are creating your interaction, you can just start at the initial step. So now we're okay. So I will now go on the load. In other words, the boundary condition. Yeah. So in the boundary condition, I will apply two boundary conditions. First, the constraints, and the other one is going to be the load. So the constraint is I click on here. So I'm going to give it as, let's say boundary condition one, or let's say constraint. This is the one that you set the liberty of freedom, the degree of freedom. So let's go on displacement rotation. I'm going to click continue, and here I'm going to let's say click on here. I'm going to set up my boundary condition on here, and then done. I'm going to block the first translation on X, on Y, and on Z. So for the rotation, no, I only leave them as it is. So now, okay. So I blocked all the translations. So now I'm going to apply the load. The load is going to be a pressure. Let me apply a pressure. So I'm going to give here pressure here, and then continue. I'm going to click on the other side, the opposite side here. I will click on here, and then done. I'm going to give a magnitude of 0.5 megapascal. Okay, so now I already applied my pressure. So now as I apply my load, I can go on the mesh. So in the mesh, you have many ways of creating your mesh, but I will just go on here. First, I'm going to click on parts here. Then I can click on the global seeds. So sizing control, I'm gonna use, let's say, this is a big part, so I'm gonna use 11, the global size, and then I'm gonna click OK. First, I'm gonna go on here, the star SER, and I'm gonna click on done. Why I went there to define the type of element we want to use. So, if, for example, for the interaction, the contact I have created cohesive, I would have chose the cohesive type of element. But I didn't do that. I created a contact as tangential contacts. I will use the 3D stress, so the default one. So it's fine. Okay. Now I can go on generate mesh and then yes. So I have my mesh. So if you guys want to have a very fine mesh, you could went on here the global size and reduce this into 5 or 6. Yeah. So now as I created the mesh, I can go on job directly and I can click on here, create a job. So I'm going to leave it as job 1. The job is where you do your simulation. You run the simulation. I'm just give a name as analysis. Okay. And then continue. You will click OK on here. You go back to the manager and then submit your work. It's a lean learning edition is restricted to 1,000 nodes. So I'm going to adjust the mesh because I have many elements on here and I am on restricted mode. I am on student version. So let's go back to mesh. Let's click on here. No, I'm going to go on part first. Let's click on here. So I'm going to go on 14. And then, okay, yeah, delete meshes. So now let's go again. Yes, so this is 14. Let's go to job again and see if the number of elements are okay. Submit. Yeah, now it's fine. I have elements that didn't exceed 1,000 nodes. I mean, the nodes didn't exceed 1,000 nodes. So now let's wait until the simulation is completed. Yeah, now it's marked as completed. If you guys want to see some warning or some errors, you can go on the monitor. You can see here warning here. You see some warning. These are things that you can adjust in order to have a very precise results. Yeah, and here errors. Here appears some errors, but here we have simulation. That means we have results here as it's marked status as completed. So we don't have errors, right? But if we had errors, we could have seen them here and then we could try to correct them, right? I can close it and then I can go on results. So if you go on results, you click on here, the plot contours. So now I have results here. This is the stress, 0.5 megapascal, or the highest stress. And also, if you want to display the displacement, you can go on here. The U is the displacement. So you can see if you want to pull the, let's say, the reaction forces, you can click on here, So, yeah, this is what we have. So for me, this is the way you set all this simulation. So if you want to plot a graph, it's the same way. You will go on here. You go on, no, here, let's say here, plots. And then, but first of all, I'm going to display the stress. So I'm going to see where is the maximum. So here are the maximum in the red one. So let's go on here, plot a graph, and then ODB, feed output, continue. I'm going to click, I'm going to go as the load I apply in the horizontal, in the z-axis. So I'm going to go on the z-axis, the 3 one. So I'm going to go on the stress here. It's going to be the S33 because it's the z-axis. And here the strain is going to be in the E33 because it's the z-axis, right? And then I'm going to go on plot. No, before I'm going to choose the element where I want to plot. I want to plot on this. Edit and then plot. At least should be selected. So edit here. Yeah, I want it to be selected. Edit. No, add selection. No. So maybe I will, how to say, variable here. I will change this into centroid. And then element node, yeah, now it's selected. so I can plot as it was centroid. It worked. So now I have stress strain with respect to time, but that's not what I want to have. I want to have a stress strain graph. So what I do is I'm gonna close this. I'm gonna go again on here and then operate X on Y data. And here I will choose combine. Combine, where is combine? Combine here. I'm gonna click this 2 times and this as well 2 times and then plots. So now I'm gonna have a stress strain graph. So this is the way you do this simulation, guys. So I hope that helps. Don't hesitate to subscribe, to share it with your friends, and to follow and to see my other videos. And stay tuned because there are some upcoming videos, projects, and tutorials. Peace.